Dear students, today we will learn about greedy method or greedy algorithm. Okay. So already in that previous unit, okay, from second unit, third unit, and first unit, we discussed about different design algorithm techniques, backtracking, yes, divide and conquer, and dynamic programming. Now we'll see about the another one algorithm design technique is greedy method. Okay. So in divide and conquer method, the problem is divided into number of sub problems. And these sub problems are have to combine. Okay. And finally it gives the solution. Merge sort, example, merge sort, quick sort. So these are all example for divide and conquer. And the next one is backtracking method. So what is our expected results? Okay, by using depth first search, that is start from the root node and travel one by one, and we have to move into the depth. After reaching depth, if the branch or the left or right childrens are not visited, again you have to go back and we have to visit all the nodes. Okay, so finally it gives the solutions, that is backtracking method. For that we are solved a NQ problems, M coloring problem, sum of subset problems. Then dynamic programming method, what happened? We are similar to divide and conquer. That is, the problems are divided into sub problems. Okay, but each sub problem results are stored in a table. Whenever we are again need to calculate that sub problems, no need to calculate again, just we will take the results from the previous stored in the table. So that is dynamic programming. For that we are solved 0 bar 1 knapsack problem. Okay, all pair shortest problem. Okay, traveling salesman problem and reliability design. So then the next method is greedy algorithm. So this is one of the strategies like divide and conquer to solve the problems. But this method is used for solving optimization problems. Okay, so the term optimization, what is it? Okay, let's see. I will explain briefly about what is feasible solution, what is optimized solution. So this optimization problem is a demand either maximum or minimum results. Maximum gives the best maximum result or minimum result. Okay, so let's understand through some terms. So here one problem is that P is the problem. Suppose we want to visit from the location A to B. Okay, A to B. So when we are moving to A to B, so you are using so many devices like that. You maybe go by bike or car or bus, else train or flight. So these are different solutions. We want to move from the location A to B. Okay, different subset solutions. Okay. So among from these solutions, the condition is you want to visit within 12 hours, A to B. The distance is very long. You want to visit within 12 hours. Okay, what happened that time you may choose only two options, either train or flight. Okay, either train or flight. This is the two solutions for reaching within 12 hours from A to B. So from these five solutions, these are the suggested solutions reaching fast reaching of the region A to B. So these two solutions called feasible solution. These two solutions called feasible solutions. Okay. So from these two solutions, I want to reach very quickly. Okay, train, flight. So which one is used to reach very quickly from the source to destination? Flight. Okay, only flight. So that is, this is the solution for optimal solution. From these subset solutions, the minimum cost is feasible solutions are S4 and S5. From these, the best solution is S5, flight. Okay, so that is only solution for this problem, that is called optimal solution. That is called optimal solution. Okay, now you are clearly understanding about what is feasible solution, what is optimal solution. Okay, for any problem we have different sub problems, that is different solutions are available. From these solutions, some solutions may be better. The better solutions are feasible solution. Okay, from the feasible solution, we are taking the best solution. Any one solution is the best solution to solve this problem. That is optimal solution. Okay, so feasible solution is provided by that dynamic programming, but in greedy method, it is the optimization problem. Okay, so that problem is minimizing the cost. Okay, to visit or solving the problem. That problem is called optimization problem. So all the greedy algorithms are provided optimized solutions, best solution. Okay, so that is greedy method. Okay, so now let's see about briefly what is. So we have to cover the journey with minimum cost. Okay, that means we have to cover the distance travel from the source to destination as minimum as possible. Okay, as minimum as possible. That is known as what? Minimization problem. So greedy method is one of the minimization problem. Okay, so from that previous example, one by train and another one by flight, aeroplane. So since we are traveling by train will lead to the minimum cost. Okay, it depends on condition. When you need to reduce the cost, cost wise, the train is the optimal solution. Time wise, the flight is the optimal solution. So it depends on the condition. It provides the optimal solution. So that optimal solution is also one of the feasible solution. It providing the best result among the sub solutions. Okay, so this optimal solution with minimum cost. So for any problem, there is only one optimal solution for solving the problem. So what is that optimal solution? That's we will understand, we will solve in that greedy method. Okay. So generally the problems required minimum or maximum result, then is called optimization problem. Either it requires minimum or maximum results. That problem is called optimization problem. Greedy method is one of the strategy used for solving the optimization problem. Here, what is the drawback means? Because in greedy method, it takes the decision based on the information available at each phase. Okay, so information available at current problem, and this problem cannot carry what's happening in the future. That is one disadvantage. Okay, the current problem it will take and solve it, and this problem either how it is produced the next problem solutions, we cannot consider the future. So there might be possibility that greedy solution does not give the best solution for all the problem. For every problems, that greedy method provides the best solution, but not for all the problems. Okay. So let's see about how that greedy algorithm it works. Okay. So this greedy algorithm approach is the simplest and straightforward approach. The decision is taken on the basis of current available information. Current available information without worrying about the effect of current decision in future, how it is produced the result in future, the next problem. Future means the next problem. Okay, so whatever the current available information, using this information in, okay, produce the result. It does not worry about the current decision in future. So this technique is basically used to determine the feasible solution. It may or may not be optimal solution. Okay, so feasible solution means is a subset and it satisfies the given condition. Given condition. So that optimal solution is the solution. It is the best and the most favorable solution in the subset, in the feasible solution. Okay. So this greedy algorithm, it builds one of the part. Okay, choosing the part, it gives the immediate benefit, that is better result, and never consider these choices in the previous one. And this approach is mainly used for solving optimization problem. And here the cost is minimum. So this algorithm is a paradigm based on heuristic that follows local optimal choices for each step and with the hope of finding global solutions. So many problems we are solved in a greedy method, but it does not produce the optimal solution. It gives the approximate, that is near to optimal solution in a reasonable time. Okay, this greedy method. Okay. So next one, what are the characteristics of greedy method? So the main characteristics of greedy method is to construct the solution in optimal way, best solution. So this algorithm creates two sets. One is contains all the chosen items. Another is not contains the rejected items. Depends on condition. We will select one, two set. I said no previously, if you want to move from source to destination, you are moving to so many vehicles you are using, car, bike, bus, train, flight. That depends on condition. So cost wise, you may reject car, bike, bus. So you may choose only train. So train and flight, these are all chosen items and another items are rejected items. So it makes good local choices in hope that the solution should be either feasible or optimal solution. Either it may be feasible or optimal solution. And what are the contents of greedy algorithm? Okay. So here have 5 functions. These are the components of greedy algorithm: candidate set, selection set, function, feasible function, objective function, solution function. What is candidate set? So it is a solution that is created from the set. Suppose here we want to move from source A to destination B. I said no, there are so many possibilities. You may go by car, bike, or car, or bus, else train, else flight, air. So we are created some set from the set, that is the candidate set. These are all candidate set. What is selection set? So this function is used to choose the candidate or subset which can be added in the solution. Okay. So from that set, want to minimum cost and fastly you want to reach the place, you may choose it as either train or flight. Fastest solution. Minimum time required. Okay. Feasibility function. So it is the function used to determine the candidate or subset that can be used to contribute to the solution, whether the solution is contribute or not. So here we are choose train and flight. These two are the feasibility solutions. And the objective function is used to assign the value to the solution or the optimal solution or partial solution. And the solution function means it is the function used to intimate whether the complete function has been reached or not. So these are the components of greedy algorithm: a candidate set, selection, feasibility solution, and objective function, then solution function. Now, where we are using that greedy method or greedy problems. Okay, so it is used to finding the shortest path from one node to another node. Shortest path. Okay, and it is used to find a minimum spanning tree. Minimum spanning tree, that is Prim's algorithm and Kruskal's algorithm. And this greedy algorithm is also used in solving job sequencing with the deadline approach. Okay. and it may be also used to solve fractional knapsack problem. Okay, so our syllabus also similar. The next topics are same: critical algorithm, job sequencing lines, spanning tree, and finding shortest path. Okay, let's see one by one. So before that, I said no how the greedy algorithm it works. So it is follow the optimal solution at each stage instead of finding the global solution. Okay, so in this example, this is the source and this is the destination. So there are three possibility solutions. This is one way reach destination, this is another way, and this is another one way. So you have to travel from the source to destination at minimum cost. So there are three possible solutions, that is 10, 25. So among these, which is the minimum cost? 5. Okay, so 5 is the minimum cost path, so it is the optimal solution. Okay, so this is the local optimum, and in this way you have to find out the local optimum at each stage in order to calculate the global optimal solutions. Okay, so now let's see about where these methods are used in different applications. So these greedy methods are used optimization problem solving techniques. Okay, optimization problem solving techniques. So this how this problem is work. As I said, no, for each problem. So this is that. Sorry. So you want to reach from A to B destination. What happened? We have different solutions. 1, 2, 3, 4, 5. These are all subset solutions. This is n number of solutions. Suppose A1, A2, A3, A4, A5, n number of solutions. Okay, n equal to 5. And A is any one subset solution. Okay, so for I equal to 1 to n do, okay, 1 to n, n is 5. From 1 to 5. Okay, you have to select A. First, you have to select one by one A. If it is a feasible solution, that result is X. Suppose A2 is gives feasible solution, it is X. A4 is gives feasible solution, that result is X. So if feasible of X, then you have to add all that X with the solution. So solution is added with that all the feasible solution. Suppose A5 is also feasible solution. So finally we have to add all that solution, we can get the optimal solution. That is greedy algorithm works. So greedy algorithm A comma n, A is that number of subset, n is the subset problems. Okay, n equal to how many total number of subset? 5. So for I equal to 1, that is initial, first A1 to 1 to n do. So select that A, whether it is feasible of the solution A, then we have to add the solution X with that result. Okay, that is greedy algorithm. Okay, so finally, as I conclude, so greedy method is a technique. Okay, it is not an algorithm, it is a technique. So this is the simple and straightforward approach. You have to design decision is taken on the basis of current information, current available information, without worry about that future current decision of in future And this feasible solution that may or may not be optimal solution. So feasible solution means it is the subset that satisfies the condition. From that condition, one of that subset is gives the best result, that is the optimal solution. Okay. So the character contains each optimal solution may contains two set. One contains the chosen item, another one contains the rejected items. Okay. So what are the components of greedy algorithm? That is, the first one is candidate set, selection set, feasibility function, objective function, and solution function. Candidate set means created from this set. So we have to create what are the possibility, solve the problem. Okay. And the selection means you have to choose the best candidate to be added to the solution. Suppose car, sometimes car may be provide the best solution. So we will choose car is one of the feasible solution. Okay. And the feasibility function means it is used to determine whether the candidate can be used to contribute to the solution. Okay. If you are using car, bus, or train, these are the, if you are using, these are the feasibility solution. Remaining are rejected. Bike and flights are rejected items. So the objective function is provides the assign the value to the solution, partial solution. Okay. So if you are going by bus, how much time it takes, how much the cost. The same thing if you are going by train, how much time it takes, what is the cost. You have to apply the partial solution. And solution function, so if you are going by train, the time is reduced, cost is also reduced. It is the solution of the problem. Okay. Solution of the problem. So I will explain with one example. Okay. So as I already said, no. Where we are using, what are the applications of greedy? Finding the shortest path from source to destination and finding the minimum spanning tree. That is finding the minimum cost from that one source to all the other source, and job sequencing with the deadline and finding the fractional knapsack problem. Okay, you know that what is knapsack problem? Knapsack problem means it is a bag. You have to fill the material within the bag. So the capacity of bag is 5 kg. Then you have to hold up to 5 kg material, but you have to layer or earn maximum profit. Okay, earn the maximum profit. For 5 kg of bag, if you are filled with 2 kg, then it is not a maximum profit. Okay. And if you are filled up to 5 kg, above 4 kg, then it is the maximum profit. Okay. Suppose if we have 1 kg, 2 kg, 3 kg, 4 kg. So if you are filling 1 kg, not maximum profit, 2 also not profit, 3 also not profit. So have 4 kg of weight, then 4 kg you have to fill in that knapsack. So this is the best solution among all the subset, and these are all rejected items. Okay. So I said, no, you have to find the minimum cost from source to destination. Okay. So these are the node A, B, C, D. Okay. It is an undirected graph. You may be visit from any place to any places, but you have to reach the where you are started. The same source place you have to reach and final. Visiting all the nodes, again you reach to the source node. Okay, the condition is start from the source node. So A is the alphabetic. So you started from A, visit all the node exactly once. Okay, only one time you visit all the nodes. And finally, after visiting all the nodes, again have to reach the same source place. That is A only. That is the problem. Okay, for that you have to find out the minimum cost. So how can you know that minimum cost? Started from A. Okay, so there are three ways. One is reach C, one is reach B, one is reach D. These are the three ways. Okay, so we have, if you are choose, if you are choose A to C, so how can you solve this problem? A to C, C to D, D to B, B to A. So what is the cost? 42 plus 12 plus 34 plus 20. Again, we are reached to A. Okay. So this has also another one problem. That is, you may be visit A to B. Okay. That is A to B, A to C, C to B, and B to D, D to C. A. So what is the cost? 42, 30 plus 34 plus 35. Okay. And another one solutions are A to B, B to D, D to C, C to D. This is one solution. Another one solution is A to B, B to C, C to D, D to A. This is also another one solution. Okay. So the next one is, suppose if you are visited A to D, D to B, B to C to A. That is one solution. Another one solution is, what is that? A to D, D to C, C to B, B to A. So these are all the different solutions. So from this solution, which is the best? Okay. So how can you find? So A to B. Okay. A to B cost is 20. So 20 plus B to C 30. Okay, you choose either D is 34 and C is 30, which is minimum 30. So 30 plus, now we are in C. C2, which is the minimum cost, A again 42, but we are not able to visit D. So C to D is 12. So 12 and D to A is 35. So this is the minimum cost. Okay, minimum cost spanning tree. A to B, B to C, C to D, D to E. Okay. Okay, thanks to all.